Google just launched something that sounds like science fiction, but it's about to reshape how we think about artificial intelligence forever. They're sending computer chips, the same ones that power ChatGPT and other AI systems, into space. Not just Google, but a whole wave of companies are racing to build what I call data centers in the sky. After spending months researching this trend, interviewing engineers, investors, and policy experts, I've discovered something that will fundamentally change who controls AI in the next decade. And if you're using AI for work, investing in tech stocks, or just curious about the future, this affects you more than you realize. Let me tell you what I'm convinced. This isn't just another tech experiment. It's the beginning of a new era. The context, it's already happening. Here's what's actually going on. Google has a project called Suncatcher. They're planning to put satellites equipped with their custom TPU chips in orbit around Earth. Meanwhile, startups like StarCloud just raised $150 million to launch NVIDIA's most powerful AI chips into space. We're talking about the same H100 chips that cost $40,000 each on Earth, floating 300 miles above us, crunching data 24/7. You might think this sounds expensive and unnecessary. I thought the same thing initially. But after digging deeper, I realized we're missing the bigger picture. This isn't about moving our current computing to space, it's about unlocking capabilities that are physically impossible on Earth. Why space? The technical revolution. The breakthrough isn't just technological, it's environmental. Space offers three things that Earth simply cannot: unlimited solar power, perfect cooling, and the ability to process data instantly where it's collected. Think about it this way. Every major AI data center on Earth faces the same two problems: massive electricity bills and enormous cooling costs. Google spends billions keeping their servers from overheating. In space, you have 24/7 solar power, and the vacuum of space acts like the ultimate air conditioning system. Heat just radiates away naturally. But here's the real game changer that convinced me this will succeed: latency. When a satellite captures an image of a wildfire or tracks a military movement, that data currently has to be beamed down to Earth, processed in a data center, and then the results sent back up. We're talking about delays of hours or even days. With AI chips in space, analysis happens instantly, right where the data is collected. I interviewed engineers working on this technology, and they told me something that changed my perspective entirely. One said, "We're not just moving computers to space, we're bringing intelligence to the edge of human perception." Another described it as giving satellites their own brains. The strategic reality: it's about power, not efficiency. After analyzing the economics and talking to defense experts, I realized this trend isn't driven by cost savings, it's driven by strategic necessity. Countries and companies are racing to control what I call sovereign AI capabilities. Here's what I mean. If you're a government and your critical intelligence depends on AI systems running in another country's data centers, you have a vulnerability. If you're a company and your competitors can process satellite data faster than you can download it, you're at a permanent disadvantage. The defense applications alone justify the investment: real-time threat detection, autonomous satellite operations, instant disaster response. These aren't nice-to-have features, they're national security imperatives. When I spoke with policy experts, they consistently used phrases like AI arms race in orbit and the new high ground. The competitive landscape: winner takes most. Based on my research, I'm convinced this will create a new tier of technological dominance. The companies that succeed in space-based AI won't just have better products, they'll have capabilities their competitors literally cannot match. Google's advantage is obvious. They control both the AI software and the custom TPU hardware. They can optimize everything for the space environment. But the real winners might be the companies solving the hardest technical problems: radiation protection, thermal management, and long-term reliability in the harshest environment imaginable. The startups I researched aren't trying to compete with Google directly. The smart ones are building the specialized components that everyone will need. Think radiation-hardened memory chips or revolutionary cooling systems. These companies will either dominate their niches or get acquired by the tech giants for billions. What this changes for everyone. For AI developers, this creates unprecedented opportunities. Imagine training AI models on real-time global data without the massive costs of downloading terabytes from satellites. Current limitations disappear when your AI can see and think simultaneously. For businesses, we're looking at entirely new service categories. Instead of buying satellite images, you'll buy satellite intelligence. Instead of waiting days for analysis, you'll get insights in minutes. Agriculture, logistics, finance, insurance, every industry that depends on understanding what's happening on Earth will be transformed. But here's what worries me most: concentration of power. The same few companies that dominate cloud computing are racing to dominate space computing. If they succeed, they won't just control how we access information, they'll control how intelligence itself is distributed globally. The timeline and what to watch. My research suggests we're at an inflection point. The technical challenges are being solved, launch costs are plummeting, and the strategic incentives are overwhelming. Google's first TPU satellites are planned for 2027. StarCloud is launching test payloads next year. The key indicator I'm watching is launch costs. When SpaceX's Starship drives costs below $500 per kilogram, which looks increasingly likely, the economics shift dramatically. Orbital data centers become cost competitive with terrestrial ones when you factor in energy costs. But the real catalyst will be the first successful demonstration. When someone proves they can run high-performance AI in space for years without failure, investment will flood in, and the race will accelerate exponentially. My conclusion: this changes everything. After months of research, I'm convinced space-based AI computing isn't just another tech trend, it's the next platform shift. Just as mobile computing created entirely new industries, space computing will create capabilities we can barely imagine today. The companies and countries that master this technology first will have advantages their competitors cannot overcome. They'll see threats before others know they exist, understand global patterns in real time, and make decisions with information others don't have access to. If you're investing in technology, working in AI, or running a business that depends on data, you need to understand where this is heading. The future of artificial intelligence isn't just in the cloud, it's in orbit, and that future is arriving faster than most people realize. This is the beginning of the space age of AI. Don't say I didn't warn you.